this project is going to be on networks. Um, by definition, the internet is a global computer network providing a variety of information and communication facilities consisting of interconnected networks using standardized communication protocols. That might sound a little daunting, but what you need to know is the internet is made up of a few hardware devices, namely modems, routers, switches, and servers that are brought together with cables emanating frequencies that transfer audio and visual data to work in both the micro and macro ecosystems. And the rules that govern these transactions are called the protocols. The first network that I want to talk about is the PAN, or the Personal Area Network. And this can be used to share data between like personal computers, mobile devices, and wearable technology, or even drones, or small devices. And also, this is what a lot of people use for the Internet of Things. If you're not familiar with the Internet of Things, it's just different devices that can be used and interconnected as well. But they usually have like maybe sensors, and they have like inputs and outputs and that get processed to make decisions. So in this slide, you see there's different hardware devices like the speaker, the television, the drone, or the cell phone. All these devices can be created using microcontrollers, and then you just create a casing around the microcontroller, or you add extra, I guess what they would call peripheral hardware. There's something called a NIC, network interface card, and that would be, you can actually see that on this microcontroller here. They have the network access port that I have highlighted, and the NIC would just be under that. So at this case, you could plug in like an Ethernet cord, and it would go to this little device and would have internet connectivity. And it also has the I/O pins, which stands for input and output. And from there, you can connect different cables. They have cables specifically made for this. So like, I want to say like anode and cathode, or there's usually different types of wires that can be interconnected from this device to another one for whatever purpose that you need, and they usually have a ground. So there is a protocol that has to be followed for this. But this microcontroller is what makes all these other devices. They can all be built around the microcontrollers, and they do have internet connectivity. All right, so we're gonna go to the next slide. The small office, home office. That's just a term that I guess like professionals would use, the SOHO. And this network gets its connection, or it takes frequencies from an internet service provider via the cell towers, and the frequency comes to the modem. And sometimes people will try to put a firewall like to block access from the outside internet, wherever it's coming from, because it is an interconnected network, to just like block out like malicious stuff that could be malicious code or improper protocol, somebody who you don't want to have access. And that is done with intrusion detection systems and intrusion prevention systems, the IDS and IPS. And from there, if the signal does go through the firewall and into the modem, it can be sent to the router, and from the router, it like emanates a signal that can be sent to the rest of the office. It creates like what we consider Wi-Fi. And also, you'll see in this network, there's also like Bluetooth connectivity, which is also in the personal area network as well. And that just allows you to share data through portable devices, and it uses radio communications. And it's also, the modem can send information either to the router and create the Wi-Fi signal, or it can be plugged directly into like a personal computer or a laptop via like an Ethernet cable. Next in scale would be the local area network, and this is just a group of computers connected by cabling to one or more network switches. Um, I haven't talked about switches just yet, but I believe I get into that in the next slide. But basically, this network is connected, and the signals get moved around the network. Generally, they use fiber optic cables that are placed in the ground. They're like dug into the ground, and these are made out of like some synthetic materials or glass, and they transfer. They use light. They use light inside of these tubes to be able to send data, audio and visual data, or the protocol for it, and it goes to these to modems, and like there will be modems in these different buildings that would then send the signal to the routers and create the Wi-Fi signals so that we can get internet on our cell phones. And this is generally what we would consider a local area network. It could be as small as like the one floor of one of these buildings or like a college campus. Generally, when you're thinking of the local area network, it's the interconnected network of about a mile or so, but it could be like a college campus or a business office. The next, and this is getting more into the macro, would be the Metropolitan Area Network, or MAN, and this is several interconnected local area networks. So of course it could be a few miles or maybe a little bit more. And these are the internet that's provided to these metropolitan area networks. It comes from like internet service providers. So everybody, like we have like T-Mobile, Bell South, Verizon is like the biggest ones here in the United States. I think like BT Globe or something like in Europe is what they do. But the signal comes from these cell towers and is collected by the modems and the different local area networks. And from there, the signal is changed to goes to the router, and then it turns into the Wi-Fi, like I said before. I looked it up, and technically, the waterways are a part of the metropolitan area networks. And I put this oceanographic buoy here because now they're actually connected to the internet. Like you might be able to see that there's a satellite on here because they collect geological data. Yeah, and just like I guess having to do with maybe temperature or ocean or water level, stuff like that. It's getting like pretty in depth and involved now. So there's that, and I think also on this slide I wanted to talk about the switches. So the internet comes from the modem to the router, then it'll go to the switch, and from here, the switch will send information to a server, or depending on where the information needs to go. This switch has different different inlets that is governed by protocols as well, but it can send information to different servers, and that's how you could create like an information server or whatnot. It'll send the information to where it needs to go, and that's not necessarily what I was going to talk about in this slide. I think I was just talking about more of the bigger picture, but that is a way. This could be several servers connected to the switch through the different lines. I think that's it for this slide. And then I wanted to also get into the wide area network. And also it shows the oceanographic buoys. And now they have these, I guess these new protocols and this new system that allows signals to go from submarines all the way to airplanes. And I thought that was really cool. I was thinking about like what if you, as a diver, you wanted to communicate with people, but apparently now oh, these these submarines can send a frequency to the surface of the water, and it can be picked up by um, by all the way to the airplanes, and maybe even like low level satellites. So I wanted to put that in this infographic too, and the satellite server up here, and also these different nodes that can be used for data collection and analysis. There's this term coined by called the Internet of Water. It was coined by the Aspen Institute, and basically um, they want to connect I guess the world via water, by way of water and information about water, and this can be used to collect rising ocean levels or water quality, and it could be used for um, I would say like community resiliency and like creating infrastructure or whatever. You have bathymetry to determine the depths of the water in different places that could be used for building. There's a lot of possible applications that I see. Of course, like water quality for the potability of water, like the ability, like so we know if it's safe to drink. I see some people are doing projects for like that are telling where maybe there was a chemical spill or pollution in the water to stay away from this, or show where to like go to clean where efforts can be best put. So I think this is a big idea. So that's why I incorporated water into all those slides. In the previous slides I showed like the pH balance, digital pH balance analysis or whatever as well. Um, I wrote a paper as well in composition and rhetoric about the dam removals, and a part of that is you have to equate for water, like where it'll go if the dam is removed. So you have to have like community resiliency structures in that. But there's kind of there should be a sense of urgency, because a lot of dams aren't really in the best working condition, and they're in need of costly repairs. So that's something. It's all in the write up too. And that is my presentation. Thank you for listening.